Hello all. Hello everyone. Welcome to this new session of on IBMI overview of jobs. Uh, let's wait for 2 more minutes for others to join in. Okay. Hello once again. Hello everyone. Let's start. So overview of jobs on IBMI. So today we are going to mainly talk about the following things. Uh, what is a subsystem? Characteristics and functions of a subsystem. What is a job? That this is the main thing that we are going to talk today. This is all part of a process called as work management on IBMI. The types of jobs, the job queue, what is a job description, job life cycle, investigating an already executing job, and how to reply to the message waits. That is, if there are some errors. Job status, how to debug a job, interactive debug and batch debug, and what is an actuation group, and then some commands for job handling, and finally we'll talk about job scheduling, and the last part is the QA session. So let's begin with subsystem. What is a subsystem on IBMI? A subsystem is we can say a pool of resources used to manage multiple jobs. It's a small environment within the OS, a mini environment, mini OS we can say. It has all everything that it requires to run a job, not one job, multiple jobs. So that is basically a subsystem. So subsystems provides a controlled environment for running jobs and managing workload distribution. So controlled environment means there is a proper systematic way these jobs are executed and completed. There is a proper authority. Not everyone can execute. Only the users that have authority on those jobs can execute it. These kind of things. Also, subsystems allocate system resources to jobs and provide isolation, ensuring that different types of jobs do not interfere with each other. So all the memory area and file connections to the files, everything it efficiently manages so that the jobs run without any hindrance or with clashes with other jobs. And how is a subsystem defined? Subsystem is defined using a object called as subsystem descriptions. So in this description object, we specify how many job queues are there, all the job queues that are attached to the subsystem, how much memory should be using, this subsystem should be using, and the routing entries. Routing entries are something like which job to call, which job queue to use, and when executing, when to change to the other job. These kind of rules are set up using the routing entries. So characteristics of and functions of subsystems. So mainly the characteristics are everything is described in the subsystem description. Then we also describe the processing environment for a subsystem. What is the memory area? What is memory area is basically called auxiliary pool. How much space, hard disk space should be used? What is the time slices to be used for each job? These kind of things are described. Then the resource allocation, how much CPU time has to be used, what is the uh, uh, other printer, what are the printers to be connected to, those kind of things, resource allocation. And as I said, routing entries, these are the rules, like different subsystems process all the jobs in the subsystem in different methods depending on the kind of subsystem that we describe. I'll explain it with an analogy in the next slide. So routing entries, isolation and control, like it's just as environment, a closed environment within which all the jobs run. If there are any other subsystem, the other subsystem will not interfere with the current subsystem, like that. And the command and operations that are required to modify the subsystem, change the subsystem description, execute, start the subsystem, end the subsystem, these kind of things. These are all the characteristics and functions. So the basically how you create a subsystem description. This is the command, the create subsystem description, and you can give some of the attributes to this subsystem description are pools, like which uh, memory areas to be used, what is the maximum number of jobs that this subsystem can hold, and the when signing on, at the time of signing on to the system, what is the display file name that has to be shown. All these things can be specified. Initial library list to be used, and who all can change or modify the subsystem. We can give, if you give star all, everyone can modify it or change the description of the subsystem, and so on. So this is one example. Earlier I showed you how subsystem command is there. This is the example. You are creating a subsystem description called as qprod. This is the subsystem, and it has memory areas used as 1 and storage as 200k bytes. So that much maximum storage it can use for processing. Then it maximum jobs that can run at a time is 6. And this is the command to start the subsystem, qbatch. Let's say this is a batch subsystem. I'm describing a batch subsystem, and you just start how to start this, start subsystem description qbatch. You can also end the subsystem. And once you end the subsystem, all the jobs also will finish processing and then end by itself. If you end the subsystem immediately, start immediately, all the jobs also end, but they end as abnormal. If you just end the subsystem in a controlled manner, that is option star controlled, then all the jobs which are currently executing will finish and then end. Now, before going to what is a job, I explained about subsystem, correct? All these things I said. So why do we need a subsystem? Subsystem is something like see, by when IBM I shipped, we get a subsystem called as by default we get the subsystem called as queue base. All the jobs run in queue base, interactive jobs and batch jobs. Like interactive jobs means whatever when you connect from a screen and you are working directly with the operating system through the interface, which is the screen. This is you are interacting with the screen, you are interacting with the operating system, but through the screen you are giving the some commands to the operating system through the screen. You're typing something and then the OS fetches that. So these are interactive jobs. And when interactive jobs are run, it has to run in a subsystem, so you create a subsystem for it. Similarly, you can without your interference in the night, let's say, or on a holiday, you need to run a job which processes a lot of records. It reads some files and it has to create a lot of reports, and it has to send these reports to a lot of departments. So, and there is no interference. You are not there in front of the system. You are not interacting with the OS through a screen, nothing. In the background, it keeps running. So these kind of jobs are called batch jobs. I'll come to that in detail again. So these things run in a subsystem. So subsystem, you can think of it as like a department in a company. So let's say uh, you are creating an accounting department. If, for example, by default, we have the queue-based subsystem, right? So it's just one subsystem where all the kinds of jobs run. So it is like a company where there is only one main department. And everyone works in the same department. Accounting people also work in the same department. Production employees also work in the same department. Everyone is in the same department, and everyone is doing accounting people are doing some tasks of production. Production people are doing some little bit accounting. It's all the job, all are doing all jobs. So it is very confusing, right? So to properly organize uh, uh, provide efficient resources to each of these. For example, accounting department may need a lot of interactive system where or let's say in a bank there is a cashier and all those people, right? Clerk and so people keep coming. So and then they say something, the cashier has to enter the name or account number into the system and fetch the information at that immediately. So these people will need a interactive many interactive jobs or interactive system for them. But at the same time, in the background behind the scenes, there will be other people who are doing data analytics or something like that. So they don't need any screen or anything. They just trigger some job which will do a analysis and calculation on a large number of records and produce some reports for them to see. So those kind of jobs, they don't need the screen or anything. They just trigger and then they see I sit back until the print reports are printed on the printer. So they need a different set of resources for them. And the clerk and cashier accounting people, they need a different set of resources. They need a display file, and their interaction, there should not be any lag. When they enter, a customer comes to the uh, counter and they enter the account number, there cannot be any lag, right? So it has to fetch the uh, information very quickly. But in the night, let's say batch, the process can, maybe there is a lag because lot of records has to be processed, but nobody is watching over it, or they want some information immediately. So these kind of processes are separated. So all the interactive system jobs are in the queue inter, let's say. That is a subsystem called queue inter. And all the batch jobs which run in the night are in the subsystem called queue batch. So it is separated. Now, let's say you want to, at one time, you want to do some maintenance. At the time, you don't want anyone to work on the screens or enter any data, but the batch jobs can run. So you can just shut down the queue inter subsystem, and you can do your maintenance. But if it was queue base, the default subsystem where everything is running together, then you will have to shut down the entire queue base subsystem, correct? So it's just for efficient use of resources. You are doing this creating subsystems. just like many departments in a company. So what is a job now? Job is a unit of work that the system performs. It is we can say it's a uh, program or a series of program, and it's called by a user. A program by itself, it will not be a job, correct? It has to be a it has to be a it has to do some work. That is, you call the program, it runs, it updates some file, it produces some reports. So this is what I am saying about job. It has to do some work. Yeah, this is when you tell a computer to run a program in order to perform some work, only then we have a job. A job, like a human, as a life cycle. A job is born, it works, it does some actions, it updates some files, and finally the job ends. It's life. We are planning how this job has to run, what programs has to be called, in what sequence, and what it should update, what files it should update, what reports it should produce, how all the job information does it have to be tracked in a job log or not, and so on. So it exists within an environment. So there is a when a job starts, there is a environment for it to run. Like there is a memory area, there is a link to file open files with all the files that you have described the programs to run. The connection is established to those files. This is a environment. The purpose of a job description is to define this environment in which the job will live out its life. Like the when you submit a job, uh, it goes into a job queue, right? So we need to tell in the job description to which job queue this job will go, the priority at which this job will run, uh, the CL command that it has to call, and when if there is a library list already when you are calling or submitting a job, it will fetch that. But some, for example, some yeah, if you have already qualified those objects, like qualify means you are saying fetch this data from library A slash file B. So library is already called there. If it is there, then it doesn't require anything else. But suppose you don't give the library name, then it has to go and look into the library list. So you can give the set of libraries that it has to look in for that file. So types of job. So as I said a little bit earlier, there are mainly two types of job. There are other jobs too, which we are not discussing in this session. I'll just briefly touch on the other types of jobs. But the main two types of jobs are the batch jobs and the interactive jobs. Batch jobs, it just runs in the background. Nobody, for example, once all the data in a day is entered in the system from different display screens, customers come in, they create new accounts, or some people place new orders, uh, or people book tickets in a railway station. All this data is there. But at the end of the day, in the night or some other time, when nobody is, everyone is shut down their display screens and gone home, all this data is taken together and processed. So these kind of process without any manual intervention, this is called batch jobs. So they just run in the, so that is one of the type of job. The other type is the interactive job, which is where a user logs in and enters some things data on the screen, and or expects enters some commands and expects an output, or runs a query to see some calculations or something, those kind of things. These are the interactive jobs. So other than this, there are some more jobs which are called like auto start jobs. Auto start jobs are like when a subsystem is uh, started. When you start a subsystem itself, some jobs has to run initially to initialize the memory areas, or uh, for triggering some other jobs, or triggering some other new subsystems that has to run at the same time. So these are the auto start jobs. You describe it in the subsystem description when the subsystem starts, or there is also a controlling subsystem by which is coming with IBM. It is called QCTL. This subsystem is the subsystem that controls all other subsystems. So QCTL is kind of a system provided IBM I provided subsystem. So when that subsystem starts, what are the other subsystems that has to be started? You can specify those in the auto start jobs. Then there are communication jobs. Communication jobs are basically from some remote system, someone is trying to connect to this particular system and requesting some um, transaction or something, those kind of things. So to handle those actions, there are communication jobs running. There are also pre-start jobs, which are like before a job is started, you need to uh, trigger this job, pre-start job. So these kind of jobs, like for example, yeah, you may need it because you have to initialize some storage pool or those kind of things. Then reader job, writer jobs. Reader job is like which reads the output from the jobs, pool files, and those kind of things. And writer job is the job that writes to the output queue. It writes these pooled jobs. Server jobs are like which runs continuously in the background, waiting for some kind of information to come in. System jobs also. System jobs are the ones that control the uh, like writing to the disk. These are system jobs are not in our control. It's from the IBMI. It starts starting the operating system, ending the sub. If you are saying end subsystem, there should be a job that is there should be a system job to do that actually. So that kind of jobs. So that is a system job. Job queue. So a job queue is also a system object. It's an object. You can also define your own job queues. And when a job is submitted, it comes and first it comes to the job queue. It is it will be waiting in the job queue to be processed. It serves as a waiting area for jobs before they are dispatched to subsystems for execution. So in a job queue, I will show with the diagram in the next slide. There can be multiple job queues. Okay. And each job queue, we can define different priorities and how those jobs in that jobs coming into the job queue has to be processed. We can define those kind of things. So in a subsystem, you can have multiple job queues. But a job queue or a job when it runs, it has to be attached to only one subsystem. The job queue cannot be attached to multiple systems, multiple subsystems. Okay. So what are the main functions of a job queue? It's storage of jobs. When a job comes into the subsystem, it is stored in the job queue. And then another function of a job queue is to submit those jobs. To submit means actually start executing. First, when it comes, it just resides in the job queue. It just stays there. It's not executing. And job submission, that is also one of the tasks of a job queue. The queue will decide when the other when this job has to start running based on all the job priority and the rules that we have specified for that job queue. Queue management. This is basically the same thing. Scheduling and prioritization. And like prioritization, uh, each queue we can prioritize. Like this is a very important queue. Anything coming to this queue has to be executed immediately, and and this is based on the sequence number we give for a job queue. You can give from 0 to like from a low value to high value. The low value uh, will be having high priority for the queue. And the commands, you can change the job queue if you can you can transfer one job from one job queue to another job queue. These kind of commands are there for a job queue. Now coming to job description. Job description is how a job should run. What are the when a job runs, what are the uh, 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 like for example, what is the priority test to use, what it is, which output queue the job has to submit its output to, and when a job is submitted, what is the initial program to run, which is a library list it has to fetch. These kind of things can be defined in a job description. So the main use of this job description is to make the every job run the same way. From wherever you submit, if you have a job description and say use this job description, every job can be standardized to use the same uh, attributes when it is running. So as I said, there are many attributes, right? Job as job number is one attribute. A job as a name, who is submitting it, and what is the priority of the job. These kind of things are the job attributes. Standardization, as I said before, uh, you can submit jobs from multiple areas, but and then from one subsystem or the another subsystem. If you are using the same job description, it will have the same standard features for that job, same initial program or same queue. It will go to the same queue, it will use the same library list, it will have the same priority, and that's what I mean by standardization. Key parameters are the priority, output queues, job queue, uh, these kind of things. And you can also change the job queue job description, and all these attributes of the job description. Here's one example. For example, you are submitting a job called costing. So the program related to this costing job is cost. This is an RPG program, cost 2741R. So you're calling this program. When this job is start executing, it is basically going to call this program. So there is a job queue created specifically for the production department, and all the jobs for production department will be submitted to job queue production, and all the output from the jobs from, for example, cost 2741R, maybe generating a report that goes. Report is also called spool file in IBM. So that spool file goes to outqueue cost ACCT, cost accounting. So you can give some text also. This is just directly submitting the job. Now, then if you are submitting multiple from some other job, for every job you need to keep on giving this job queue, out queue, everything. So instead, what you can do, you can create a job description. You can say create job description, and you can give the job description name as costing, and job queue will be production always, out queue will be cost accounting always, some text, and here you can say the initial program to be called is cost 2741R. Now you can, what you can do, simply submit the job costing, and then specify the job description here. Similarly, whenever any other job you submit, you just specify the job description. All the jobs, whatever you are, wherever you are using job description costing, will have standardized uh, same job queue name, same out queue name, etc. Output queue. So this is our, it's called out queue. Output queue is where the spool files are placed. Spool files is like uh, before printing. When, for example, if a job is running and it is generating some output, let's say a report, it cannot be directly sent to the printer and printer prints. Why it cannot be directly sent to the printer? because then what happens, for example, continuously data is many other jobs are sending data to the printer. Then at the printer end, there will be a lot of kind of crowding, right? Data is just coming in, but printing is little bit slower. It takes time. So it will just keep on buffering there. So that is not a good thing, right? So what we do is we create an out queue object. It's basically a space on hard disk only. You can think of it like that. So all the output is stored in a buffer area in a first in first out kind of order. So whatever comes first, it's like a spool, right? Spool is, where a thread is wound, right? So whatever you unspool, the first extreme end that will come out first, and then you keep on unspooling whatever the other end till the end of till the inside of the spool, the thread will come out, right? So similarly, when a job sends some data, it stores into a hard disk area. It will be here, let's say, and then this is the printer. Then the output first, whatever is come first, will come go to the printer. Once the print whatever has come up will keep on piling behind, and then once the print job is complete for one of the spool file, it will take in the other spool file that has come before that, after that. So it will fetch that and print. So that is a spool file. Now spool file has to be stored somewhere. So that the queue to store the spool file is called the output queue, out queue. So what are the characteristics and functions of a out queue? It needs a storage area. Storage for you give a, for example, you define an out queue called out queue one. So that is a area to store the spool files. Then out queue management. Out queue managements are like something like what is the priority you have to give for the out queue. Like waiting to process. You can move, like for example, you can give priority from 1 to 9. 1 is the highest priority. So if you are given a spool file priority 1 and another spool file priority 2, the priority 1 will be first moved to the out queue. Okay. So you and out queue, you can link it to the actual printers. And then so that when you from the out queue you ask to be print the spool file to be printed, then it goes to the printer and prints. Or you can store the spool file in a held status in the out queue, and then after some time, or when the system is lot of functions are free, or at the end of the day, you can release each spool file one by one, and then the it will print on the associated printers. So the attributes of the out queue, as I said earlier, it's like the order of files. You can specify the order of files on the queue depending based on the priority that you're giving. And then you can also give something like whether you want to print it now or later. You can hold the spool file stay. You can say this attribute is held star s. So it will be held on the queue. So this is a life cycle. When you submit a job, first it goes into the queue, job queue. It resides on the job queue. It is not executing. If you submit another job, it goes into the same and it's submitting to the same job queue. It will go and stay in the next before the first one that has come behind, or let's say behind. And then a job queue is associated with subsystem. So now subsystem will be running, right? It will have we have specified the job queue priority and the subsystem, how it has to execute, and everything in the subsystem description. So it fetches the job from here, and based on the priority of that job, it makes the job run. The subsystem makes the job execute, and when the job executes, it produces some output which goes into the output queue. And from output queue, when the spool file is released, or even directly, if the printer is available and free, the spool file is goes to the printer, from where this is also a job kind of thing, a printer writer. So it fetches the output queue and then directs to the actual printer and prints. So this is a diagrammatic representation. So I have a subsystem called queue inter. There is another subsystem called queue batch. So workstations are there. From workstation, each when they enter something or when they interact with the display station, a job is created, or when they sign in itself, a job is created, and it that is also in the queue. So this is, let's say this job queue is called job queue A. It has a sequence number 10, which means compared to these two, this job queue has highest priority because sequence number is lesser. So the subsystem, when it executes these jobs, it will give more preference to the one in this job queue. For example, let's say we describe this job queue as sequence number 10, and also maximum jobs that can run at a time in this queue as 3. So when the jobs come here into this queue, all these 3 jobs will run at the same time. Maximum active jobs for this job queue we have specified as 3. So all these jobs will run at the same time. This will be waiting. Job 6, 7, and 8, and all this will be waiting. So once this is complete, and if there are no more jobs here, then the subsystem will fetch from here. If this one we are saying it has to do one by one, then first job 6 will run, then only job 7 will run, and then job 8. Before by the time another job has come here in this queue, then again subsystem will move back here, fetch this job because this has highest priority. So these are the things that subsystem does. So for a queue inter, the subsystem will be more concentrated on uh, the jobs will have lesser time slices. Like quickly you have to produce or show the output on the screen, right? Where user asks and user cannot keep waiting for some output. So the queue inter is designed in such a way the jobs will have smaller time slices and quickly start executing everything. They'll give equal priority to most of the queues, other if not specified the sequence number. And then everyone will, nobody will be feeling a lag. But batch is little bit different. Batch will be like you have scheduled jobs and there is no pressure to quickly show the data or information on the screen. It will be more of a file read and output, file read, input, output, and then update. Those kind of jobs are running here. I put here also as a display session only because to show from a display session also a user can submit a job in batch. So when it's not an interactive thing, he just does a submit job command or something, and that also comes in the queue batch. So job queues, for example, this job queue can be, you if you want to, you can even link it to queue batch. You can change, you can do all those changes, but normally nobody does. Like we create a subsystem and we create different job queues for this, different job queues for this, but it is possible to change the job queue and associate it to queue batch. Or if you want to, you can move the job queue from this one to another queue. All these are possible. From job queue inter, this job, nobody usually we won't do move to queue batch job queue, because then the way the job is processed will be different, because queue batch processes that job differently. So and job queues can be is associated with out queues. So this job queue now, for now it is out associated with out queue X. So all the output will come here. From job 1, spool file has come here. The after the job 2 completed, the output spool file 2 has is residing in this queue. So whatever has come first goes to the printer associated with this out queue, which is PRT01. you can change, you can move the, if you want, suddenly this printer is not working, you can move the spool file one to this out queue and make it print. All those are possible. Okay, this is also similarly in the queue batch subsystem also. Just that the difference is how the subsystem executes these jobs, because here the priority is to show the information quickly to the user. User cannot keep entry asking something, and that information to come back on the screen, it should not have a big time gap. So the way the jobs processed here will be kind of shorter time. CPU will be used many quick multiple times for each of the jobs, shorter time slices. Okay, but here it will time slice will be for each job can be little more than the one, one in queue inter. And then there are many operating system concepts, like how the jobs will sometimes, depending on the way the subsystem is defined, it can run jobs in, first out in sequence, or it can run it in a round robin, that is equal in a round fashion, like job 22 first, 23, 24, then this one, this one, this one, this one, this one, this one. It will give each job, let's say, 1 second to process. Once 56 is complete, it comes back to 22 and it gives again 1 second to job 22, that way, round way. So that is all defined by the way the subsystem we want the subsystem to be in the subsystem description. You can even duplicate and create multiple inter subsystems or queue batch subsystems. That is all depending on the functionality. If it's a large company and one department has a lot of bad jobs to run, another department also has. So they can create another one instead of submitting all their job also to this same queue batch. You can duplicate this queue batch to queue batch one. And for one department, you can use queue batch one. Another department can use queue batch. So when the job is running, you can investigate the job, like what is it, what are the steps executed till where it is executed, and those kind of things. So you can use the display job and the job number, the person who submitted the job, and the job name. You can also use work with job command to change the job queue or something, job out queue, execution priority. You can change those kind of things, or you can end the job. So you can use the work job command. This is the on the client access system. You can right click the mouse and do the same thing. You can press system request and then press enter, option 3 there to do get the same work job command screen. So sometimes job goes into message waits, and then you have to batch jobs or interactive jobs. Anything can go into message wait. Message wait is there is some error at some particular step in the program or something, and job went into message wait. Now job will ask you what needs to be done to the. It will give you some options like, do you want to cancel the job? Do you want to take a dump of the? If it is a CL program that has failed, it will give you most of the time these kind of options. Do you want to cancel the job? Do you want to take the dump of the CL program variables? Do you want to ignore the command, failing command, or retry the failing command? If it's RPG program, you can cancel, you can take a dump. Dump is basically when you take a dump at the time of the error, all the what were all the which files were open, which are the what was the value in the program variables that we are using, what were the variables it was holding. It will give you a clean report of all the that information. If you give G, you can go back to the start of the RPG program and continue again from there, from the initialization routine. If F is again a done, but it's in a proper, a kind of formatted format. This is just one example, quick example I want to give you about handling message waits. So there is some CL program, let's say it takes in parameters, file names, three file names, and then what basically it does is just clear the file. It clears the file from this library. Uh, then it clears the second file that you have received, third file. So the so this is how you are calling the program. Let's say you want to clear the file. It's like a previous, you want to, like old archive history is there, and you want to clear those data. So you're passing, I want to clear November 23rd's file, December 23's file, and Jan 24th, 2024's file data. So you're calling, but then what happens? Let's say somehow this file, November 23, is not there in this library. So now what happens? You get a error message, right? Now file not found. So now you have a choice whether the program, the job is asking you what you need to do. Do you want to cancel it or take a dump, ignore or retry? If you retry, then again it comes to the same line, clear physical file. Again it tries to find this file in this library. It's not there. So again the same message will come. Ignore, it will go to the second line here. And then if this file is there in the library, it will clear it. Yeah, if this file also is there, it will clear it and end the program. So you can, depending on your choice, maybe it's okay if this file is not there, it doesn't bother you much. So you can just ignore the command and then make the program go to the second line and execute. If you want to retry, you have to go somewhere and see if this file is there in some other library. And if there is data, you move it to this library first. And then you ask, do I retry? Then again, the command comes to this failing line, and then it retries this command again. At the time, the file is now there because you have moved it here. It clears and then continues execution. Another example, suppose there's a data area where you store the email ID, your email ID, and then in the program, you retrieve from the data area the email ID, and then you are sending a mail. Okay, send mail to the email ID that you have retrieved from the data area line. So suppose this mail ID is wrong, and then the program fails, saying that recipient is, this command says this recipient is invalid. Now, if you, and it gives you again the option ignore and retry. Now, if you do a retry on this job, what happens? It comes back here and the email ID is still the same thing. It is not changed, right? Even if you change the data area with the, and you input the, now you remove this and put the correct email ID. And then if you retry, will it work? It will not work because this variable is still holding the old email ID. So it will not work. So all that you can do is ignore or cancel, end the program, then change the email ID and call this program again. When you call this program again, when it comes to retrieve data area, it will retrieve the correct email ID and then send the email. So this is how you work on the jobs which are failing. So you correct it, and then if you rerun the program, it will send the mail. Then you can also, when the job is executing, you can see the job status. You can go and say work job command, as I said earlier, you can see the job status. It can be active. Active means it's running. Out queue. It has completed and it has generated something in the spool file. You can go to the out queue and also look at the spool file. DSC is when you see the job status DSC, it means it has disconnected. And job queue is, it is job queue has been submitted by a user or by the system or some program, and it is waiting in the job queue. It is still not started execution. System request, it has been suspended due to system request. System request is something like some kind of someone is saying cancel it or transfer it, those kind of requests. FIN status is it has completely finished its execution. Whether it worked fine or not, we don't know, but it's finished. end. If it shows end, someone has gone and tried to end the job, but they have used the controlled option. So it is ending a little bit slowly, not immediately, uh, suddenly. But it is ending. When you see the status, the job will in a few seconds or in a minute, it is going to end. End of job. This is other than someone ending it or ending the subsystem or something. Mm, Other than that, some other thing, some like say, like for example, someone signed off or someone there was some kind of error in the IBM itself, and this job is now ending. Message wait is when there is some errors. Usually it will be interactive also can show a message wait, but usually it will be most of the time bad jobs. So debug. We can go when a job is running, it may be calling multiple programs, and somewhere in that sequence of programs, some of one program is doing some error calculation, or there is some message wait, something is happening, or there may not be any error or message wait. S- some logic is not working correctly. You want to go step by step and check it out. So you can do a debug all these jobs also. Interactive job debug. You can first prepare the environment, like all the necessary files. You can bring it to your own library or something like that, and yeah, create the necessary data. Then you can start the debug session by using start debug command, strdbg or strisdb commands. You can start a start debug session. You can give the program name in the start debug command, strdbg, and then the program name that you want to start with. When you begin the debug, you want to start from which program. You can give that program name, and it will show you the source code of that program. You can go and provide breakpoints on whichever line you want to execute without. If you don't want if you want to execute step by step, then you don't need to give breakpoints. If you give breakpoints, then till that step in one go you can run it, and from then onwards you can do a step by step. So that is why breakpoints are needed. And once you do that, then you can go by line, check on the variables what it's holding at that point in time, and then you can also change the variables and see if you change the variable what happens, and then you'll find what is the cause of the problem that you are investigating. So bad job, debugging a bad job is also similar to interactive, but with a slight extra step. That is, you have to start the service job first. Once you submit the job, you have to put it in held status so that it's not running, and then you have to start the service job. That is a job that uh, works on this submitted job itself. Okay, so you have to start a service job, then start the debug session, and once the debug session is there, it will show you the module or code source. You can put the breakpoints, everything. Once that is all set up, then you can release the job. And then when you release the job, the service job will take the control to your program wherever you have put the break point. It will bring you there, and from then onwards you can do the debug. So this is an example. Submit job. You are saying call program, and held hold on job queue. You are saying star s here. So this program you want to debug, and when you are submitting it in batch, yeah, hold on star queue. You are giving us yes. So this is the command, hold star s, submit job, some parameters you're passing. So in the job queue, work with job queue, work job queue if you give, and give the job queue name as a PIO job queue, you will see the job shown here, and status as held. So you can take this job information, job number, and user ID. These details you can take, these job attributes you can fetch, and then actually this is the program, right? This is the one you want to debug. You want to know why it is failing in this line. So you want to see. And once you release the job, it will show you this source. That is, you go and go back to the word job queue. You give option 6, release. Then from held status, it will release. So actually, previously you have also set up the start service job. Okay, I didn't. You have to also give the start service job command here. Okay, after this step, after you held, you after this status is held, you also have to give start service job, and you give this job details to that start service job command, and then it show you the source. You can put the breakpoint, and then you can release the job. Once it releases, the service job will show you this screen, that is service job has now started. And now you enter the press enter to start the job, or F10 to start debug. You can add the breakpoints here. Once you set up, for example, directly you want to run till here, and then you want to do step by step. So you have added a breakpoint on line 7. Using, you can keep the cursor here and press F6 to set the breakpoint here. Then you press F12 two times. That is, F12 is it is resume, that is run the program, start running the program till the breakpoint. So you do this two times, and then you enter. The control actually comes into this program at this line. Now if you press F10 step, it goes to the next line, and if there is some error, it will, you will realize it has failed here. See, when you press F10, it was the message wait has appeared. So waiting for reply. This is the message wait. Now you can take action, and but you understood the source of the problem in the debug mode, and then you can close this. You can cancel the job or do everything, complete it. And when you enter F3, the service job also will get ended. End debug and then service job. So finally, last one more thing I'll just touch upon is called activation group. What is an activation group? An activation group is a resource container, and it's within a job. It's not outside a job, it's within a job. Once the job is ended, the activation group is also closed and clear. And what is a container? A container contains a bunch of activations. That is why we say it's an activation group. Now, what is an activation? Activation is a reference to a storage allocation or a link to a file. The program is using some file, let's say. So it's a pointer to that file, or a program has read till 8th record. So it's a pointer pointing to that 8th record in the program. And the activation is group is usually for a ILE program, not for a OPM program. So there are two types of activation group: default activation group and ILE activation group. ILE activation groups are like, there are many types. User named, you can give your own name. Callers activation group, that is, program A is calling program B. So program B can be compiled using saying that use the callers program A's activation group. So then program B also will use the same activation group that is being used by program A. Okay. If you give a new activation group for a program, when the program starts executing, it will create a new activation group for itself. So there is program A is calling program B. Program B is also compiled as new activation group. So then that also will have a new activation group. QIL is it's not the default activation group. Default activation is group is different. QIL is the same as the new activation group only. Just that if you are not giving a new activation group or username or anything, it will by default take the name as QIL, and that program will submit a create a new activation group. So this is just a quick example of activation group. This is in the OPM model. OPM model is the old model. ILE is the new kind of system that is uh, upgraded version in the ILE in the IBMI system, right? ILE is created because, for example, earlier when program from RPG program, you call a C program, let's say. So RPG program will create its own memory. C program will again create its own memory area and environment. So it's actually a overhead. If at all RPG program is reading one file and then it's pointing to some record. Now you called the C program. Actually, you wanted the C program also to work on the same record, but C program will actually create another its own environment, and to make that pointer point to the same record, it is very difficult. You have to open it share mode. You have to. It's not even possible. So, but in ILE, what is happening is we are now trying to reuse programs written in other languages like Java also. From RPG program itself, you can call, but you don't want to that Java program to create its own environment. You want to use the same environment that program one is using. So in that case, you can the Java program that is written as a service program or something that will be using the star callers, that is RPG's activation group, star caller activation group. So this is the old model. Like old model program one runs, it has its own activation group in which there is pointers to the this is reading some file, let's say file one, and then somewhere in the program it is on record two. So this activation group is storing the pointer to record 2 here, right? And then after that, when the pointer is here, you are calling program 2. Now program 2 is some other program. It's a different program or in a different language, or even in same RPG language itself, let's say it's a different program. But when this program starts executing, it creates its own activation group, and it has its own variable area, memory area for its storing its own variables and overrides and everything. And you have read in this program, you have read record 4. So now it is pointing to here. When you come back, still it is on record 2. So this is how it is. So this is not efficient. For example, sometimes you want program 1 uh, to point on record 2 and then call program 2, and program 2 also you want it to function on record 2 itself. So the unless you design it in such a way that you have to make this file shared, even if it's shared, if it is in update mode, it's very difficult to two, three programs to open the same record at the same time. This kind of things. It was different activation groups. Now, for example, in ILE, what happens? Program 2, you are saying, I will use program 1's activation group. That is, whoever has called me, I will use the same activation group. So program 1 has created one activation group here, and it is pointing to record. First, it is pointing to record 2, let's say, and then it called program 2, and then it read to program record 4, and then it returned. Now, in this program, the pointer is now on record 4 because this has changed it to here. So what I'm trying to say is both the programs are using the same activation group and the same resources activations defined in the activation group or being used in this activation group. So this is what is the function of activation group. It is to use, reuse, or the resources efficiently, or otherwise what happens, everything opens in different activation groups, so many memory areas, pointers, it's a overhead, and when program one ends, the activation group is closed, and again program one is called again somewhere, again it has to initialize all this activation group, environment, pointers, variables. It has to clean up and do it again. That's the purpose of activation group. So these are some commands, as I said earlier, work job. When you do a work job, you can see this way, and then you can put an option 10 to display the job log, and you can see the job log. Each command, this is a job log for an interactive session. So you can see all the uh, commands that you have entered on the screen. Then there is a work with active jobs where you can see all the jobs in each of the subsystems. There's a queue batch system. There is the jobs here. Then there is a HTTP server subsystem and all the jobs running in here. And there are in different statuses. Some are in waiting for some signal. Some are waiting for some event, and so on. The work with active jobs will show also the CPU percentage and all those things. So to show all this information, it takes little bit time for this. It's a resource intensive command, so it will be using CPU and all. There will be a lot of overhead. So if you don't want to see the entire jobs in all of the subsystem, and you want to see only some specific jobs in some specific subsystem, then you can use subsystem jobs. When you say work with subsystem and then you give the subsystem name, only the jobs that is on that subsystem will be shown. User job, uh, you can give your if you want to see only the job submitted by you, you can give work user job user and your username, and you can see only the job submitted by you. Most of the time we are interested in the job submitted by us, whether it's running or it has gone into. See, this job is in active status and there is some other job which is in this is the one that is interactive job. So it is this session itself which is inactive. There is some job batch which you have submitted in batch. It's in the job queue. It is in held status. So you can see other users jobs also if they have given sufficient permission. Spool file, to see the spool file you have to see the work spool file output and star it will show all, or you can see the print. You can see all the spool files in the out queue also. You can say work out queue, and you can even also uh, change the parameters related to this out queue using work out queue, and you can change the uh, printer file associated with it and those kind of things. There's one more thing about jobs. There is, you can also schedule the jobs. For example, tomorrow morning 6 o'clock I want to run a job. I can do a scheduling of that job, and then at the 6 o'clock exactly it will submit, it will start running. So in that case, it will be in the job queue. It will come to the job queue at 6 o'clock, and then the subsystem takes from there to get it executed. So benefits is of job scheduling is you don't need to be there to submit it or anything. Anytime, uh, this one, any day, any second, everything you can, or you can give frequency every 1 hour. I have to run this job. That way, you can also like restrict users. Nobody can else access when you schedule it, and also you can give calendars associated with. For example, you want to run the same job, like process all the orders in one country, let's say in USA and then also in Britain. So it's the same job, but the orders are data is different. But in Britain there is a holiday on, let's say, Feb 10th, and in USA it's not there. So you can run the same, schedule the same job. You can for USA you can use USA calendar, which will run on the job will run on Feb 10th because there is no holiday. And when you schedule it in Britain, you can use the Britain calendar in which 10th will be holiday. So on 10th it will not run. These are the commands to schedule jobs: add job schedule entry, change job schedule entry, hold and release. One example here, add job schedule entry. There is a month end job running. It will call the program called inventory. It has to run on month end, time at 11:30 p.m. frequency every month, and this on this date, December 21st, you don't run it even though it's a month end. So there is one more parameter you can give, omit date. More, there are more like holiday, which holiday calendar to use and all those things. There are commands. These are all the commands. Most of them we discussed: delete job queue, change job queue, start subsystem, end subsystem, work user job, hold job, release job. So with this we come to the end of the session. If you have questions, you can ask.
Yeah, thanks, Prajesh. So from the participants, if anyone have any doubts or questions, so you can put in the Q&A box so that Prajesh can answer. Okay, we'll wait 2 more minutes. If anyone have questions, so you can put in the Q&A box. After 2 minutes, we can wrap up this session. Okay, I think there were no more questions, so we are good to wrap up this session. Thank you, everyone. Thank you, Prajesh.